Chapter 3 discusses solving and graphing inequalities. The good news about Chapter 3 is it's simply an extension of Chapter 2. Therefore, it's not going to be as long as Chapter 2 was. We're just going to discuss exactly what an inequality is and how to graph that. If you would, make sure you download the PowerPoint from the website before listening to this voice thread. Again, be sure you're taking all of the same notes on your PowerPoint as we are taking on ours. Once you've got that done, you're ready to begin. Let's go. So in Chapter 2, we discussed how to solve equations. Almost every equation that we solved came down to the variable equals one specific number. In this chapter, we're extending that and saying that the solution of an inequality is any and every number that makes the inequality true. So there are going to be lots of solutions. There is one rule that you must memorize for Chapter 3. Anytime that you multiply or divide both sides of the inequality by a negative number, the inequality sign is going to change the direction. It's going to flip directions. This slide is just giving you a general overview of what the different symbols mean. It's meant to be a resource tool for you as we go through the remainder of the PowerPoint. Just as a refresher, our first symbol is less than. Second symbol, greater than. Third, less than or equal to. And the fourth symbol is greater than or equal to. If you look down at the bottom, your less than and greater than signs are represented on the graph by an open circle. Your less than or equal to and greater than or equal to signs are represented on the graph by a closed circle, and that will be important in the slides to come. As I mentioned before, when we're solving inequalities, we're solving them exactly like we did when we were solving equations. The only difference is the rule I told you must memorize, that if you multiply or divide both sides by a negative, you have to flip the direction of your inequality sign. So in example 1, if we're solving for v, we must subtract 2 from both sides. And we're left with v is greater than 3. Second example, we're trying to solve for x. In order to get x by itself, we have to divide both sides by 2. And we are left with x is less than or equal to 5. Our third example, we're trying to solve for n. Subtract 4 from both sides. You're left with 1/2 n is less than 16. And in order to finish out the problem, you must multiply both sides by the reciprocal. 1/2 times 2 cancels, and you're left with n. 16 times 2 is 32. Again, your check work is exactly the same with solving inequalities. You want to make sure both sides are equal. So let's practice that. And I'm going to use our third example, and I'm going to use this clear space up at the top. 1/2 times 32 plus 4, and we are going to see if it equals 20. I did change the sign to an equal sign just as a reminder that I'm trying to get both sides to be equal. 1/2 of 32 is 16 plus 4 equals 20. And 20 does equal 20, okay? That means our work has checked out, and therefore n is less than 32 is our correct solution. We're going to practice a few more inequalities. In our first example, we need to combine our like terms. 6 minus 7 leaves us with b minus 1 is less than or equal to 5. We need to add 1 to both sides, and you're left with b is less than or equal to 6. Our second example, we've got some fractions, but we're still going to solve using the same process we've used the whole time. So first thing to do is subtract 1/2 from both sides. Three-fourths x comes down. Our sign comes down. And when you say 15 minus 1/2 in your graphing calculator and then hit math and enter 2 times, you're going to get 29 over 2. To solve for x, we must multiply both sides by the reciprocal. So 4 over 3. Four over 3 and 3 over 4 cancel out, leaving us with x is greater than, and when you say 29 over 2 times 4 over 3 and hit math, enter, enter, you're going to get 58 over 3. Now that's a pretty odd looking fraction, so we're going to want to check our work. Again, when you're testing your check work in inequalities, you want to set both sides equal to one another. So you would say 1/2 plus 3/4 times 58 over 3 is equal to 15. Anytime you're plugging fractions in the calculator, you must use parentheses, so make sure that you've got all of your fractions in parentheses, and you will find that it gives you 15 equals 15. So that fraction is the correct answer. Just looks a little crazy. Our last example, subtract 9 from both sides, and you get r is greater than or equal to -9. Since the solution of an inequality is not just one number, it's many numbers, you can use a graph to indicate all possible solutions. So let's go ahead to the next slide and discuss how to do that. Our first example says x is less than 3. I've given you a couple of blank number lines that we need to label. The first thing you always want to do is put 0 in the middle of your number line. You want to put a -3 and a +3 in their respective places on the number line. I didn't draw 1 and 2 and the -1 and -2 just for space. Okay? You're also going to want to put numbers on the number line beyond where your starting number is going to be. So we can just write down a 6 over here. Well, in our example, it says that x is less than 3, meaning that 3 is our starting number, but it is not included in the solutions. Therefore, we're going to draw an open circle around 3. Well, what is a number that's less than 3? 0 is one of those numbers. So all of the numbers less than 3 are going to be included. And generally, you're going to represent this by a dark bolded line that goes over top of your number line. Okay? Our second example, m is greater than or equal to -2. Again, 0, -2, -4, and then we'll do 2 and 4. Our starting number is -2, so I'm going to put a closed circle around -2 because -2 could be a solution because of our equal to sign. Well, what is a number greater than or equal to -2? Well, any positive number would be a solution. So your graph should be going towards the positive numbers. Okay? In our third example, our solution is written backwards. You always want your variable to come first and your starting number to come second. Well, our inequality symbol was opening towards -1 in the first example, and it still has to open towards -1 when we flip it around. So everything in the problem completely changed directions. Now we're ready to graph it. Again, 0 in the middle, -1, and then we'll do +1. Sorry, this is a little bit close together. And then we'll put a 3 and a -3. Our starting number is -1. It is included, so we're closing our circle. And then we have to include all numbers less than -1. Well, -3 is less than -1. Therefore, my arrow goes towards the negatives. Now we're going to do a few inequalities where we have to actually solve for the solution. Now we're going to do a couple of examples where we have to solve the inequality in order to find our solution. In the first example, we have to add 7 to both sides. You have 3x is greater than or equal to 6. Divide both sides by 3. And you're left with x is greater than or equal to 2. So we need to get on our number line here and write down some points. Now our starting number was 2, and it is included because it's a greater than or equal to sign. So we're going to have a closed circle at 2. And we are going to shade the area where the numbers are greater than 2. Well, 4 is greater than 2, so my arrow should shade farther into the positives. In our second example, we need to distribute. It's our first step, just like we would if we were solving an equation. So we've got 10w minus 40 is greater than 7. Add 40 to both sides. And you have 10w is greater than 47. Divide both sides by 10. And you have w is greater than 47 over 10. Well, when we've got a fraction as our solution, sometimes it can be hard to figure out exactly where that fraction should go on the number line. So what I'd like for you to do is do 47 divided by 10 in your calculator, and you get the decimal 4.7. Well, 4.7, we know, falls between 4 and 5. So let's go ahead and put our numbers down. 0, we'll count by 2's. 2, 4, 6, and then we'll go to -2. Well, if 4.5 is between 4 and 5 and it's not included, our circle should be open close to 5, more in between, but it's going to overlap with your 5 a little bit. The numbers greater than 4.7 shade farther into the positives. And our last example, again, we distribute. However, our distributing problem is a little bit backwards. No big deal. So we have 2 plus 5y plus 5 is greater than or equal to -3. We need to combine our like terms. So we would have 5y plus 7 is greater than or equal to -3. You would subtract 7 from both sides, and you would be left with 5y is less than or equal to -10. Divide both sides by 5, and you have that y is less than or equal to -2. Again, to graph that, You're going to plot on your, and I'm going to put my numbers up above the line just for simplicity's sake. Plot our starting number, which is -2. It is included, therefore we must close our circle. And we are looking for the numbers less than. Well, -4 is less than -2. So I need to shade my graph farther to the negatives. Okay, so now that we've practiced graphing our solutions, we need to practice solving the inequality and then graphing our solutions. When you're solving your inequality, again, it's just like solving equations. You use the same steps. So in order to isolate x, the first thing we need to do is add 7 to both sides. You're left with 3x is greater than or equal to 6. Last thing we need to do is divide both sides by 3. Our 3's cancel, and you're left with x is greater than or equal to 2. Again, we always put 0 on the graph. Put some of your numbers on there. 2 is our starting number, and 2 is included, so we're going to put a closed circle on 2. And we're including all of the numbers greater than 2, so we're shading farther into the positives. Our next example, first thing we need to do is distribute the 5. So we have 10w minus 40 is greater than 7. Add 40 to both sides. You're left with 10w is greater than 47. Divide by 10. So you have that w is greater than 47 over 10. However, when you're graphing a fraction, sometimes it's easier to figure out where that fraction belongs on the number line if you go ahead and convert it to the decimal. So 47 over 10 converts to 4.7. So let's go ahead and draw the numbers on the number line. So 4.7 is between 4 and 5, but it's closer to 5. This is going to be an open circle. And we're looking for the numbers greater than 4.7, so we're shading towards the positive. In our last example, we need to distribute our 5. Even though it looks backwards, we're still distributing. So we're left with 2 plus 5y plus 5 is less than or equal to -3. We need to combine our like terms, which gives us 5y plus 7 is less than or equal to -3. If you subtract 7 from both sides, you would have 5y is less than or equal to negative 10. Divide both sides by 5 and you have that y is less than or equal to negative 2. So since I've run out of space here on the bottom, we're going to put our numbers on the number line up above your number line. So we'll do 0, negative 2, negative 4, and then we'll put a 2 over here in the positives as well. So our starting number is negative 2, and it is included, so we are going to put a closed circle at negative 2, and we are looking for the numbers that are less than negative 2. Well, negative 4 is less than negative 2, so we are shading farther into the negatives. Okay, so I'm going to give you a couple of steps on how to write inequalities when you're looking at a graph. The first thing you always want to do is put your variable on the left, put your starting number on the right, and you want to leave a space for the inequality symbol. Second thing you'll want to do is look at the graph. Think, are the numbers in the shaded area greater than or less than your starting number? The third thing you'll need to do is think about, does the graph include the starting number? So do you have an open or a closed circle on your graph? And then last, you'll need to insert the appropriate inequality symbol between the variable and the starting number. Okay, so let's use our steps here when we're looking at the graph to determine what our inequality should be. Always put your variable on the left and put your starting number on the right. The starting number in this case is 0. And notice we left a space for our inequality sign. Well, our shaded region is in the positives, so these numbers are greater than 0. Since we have an open circle, we are not including 0 in our graph, and therefore we do not have an equal to bar underneath of our sign. Same process for the second example. Our variable goes on the left, our starting number, 4, goes on the right. The numbers in the shaded area are less than 4, and since our circle is closed, it should be a less than or equal to sign. Third example, variable on the left, starting number on the right. Our shaded area goes to the area that is greater than negative 3, and it is not included, so we just leave the symbol as is. Okay, so we've discussed how to solve and graph inequalities, how to write an inequality when looking at a graph, and now we're going to discuss the steps for solving inequality word problems. First thing to do is read the entire problem. Next, you'll want to write down the main idea of what you're comparing, and then you'll want to identify the important information, either using a box, underlining, highlighting, some way to identify that important information. And then you insert that important information into the inequality. So let's practice. Before we start on examples, I just wanted to give you a list of some inequality words that you might be used to seeing in the problems. It's very important to note that these signs on the slide are only true when your variable is on the left and your starting number is on the right. So you can use this slide as a reference. Okay, so in example 1, the dog weighs at least 75 pounds. You're going to put your variable on the left, your starting number on the right, and it says at least, meaning that 75 pounds is the smallest amount of weight that that dog could have. Therefore, the weight has to be greater than or equal to 75 pounds. Example 2, the temperature in this room is at most 70 degrees Fahrenheit. Put a variable on the left, your starting number on the right, and at most is saying that it cannot be any higher than 70 degrees. Therefore, the temperature has to be less than or equal to 70 degrees Fahrenheit. In our third example, we have twice a number increased by -4 is fewer than 10. So this is bringing in some of the information we learned in chapter 1. So we have 2x plus -4, and we're going to leave a space there for our inequality sign, and then 10. Well, it's saying that twice the number increased by -4 is fewer than. So those are going to be smaller than 10. Now we have to solve for x. Of course, we know that we get rid of that double sign. So you have 2x minus 4 is less than 10. Add 4 to both sides, and you have 2x is less than 14. Divide by 2, and you're left with x is less than 7 for your solution. Our next example, your truck can carry no more than 2 tons. Put a variable on the left, 2 tons on the right. And if we can carry no more than 2 tons, that means that the most we can carry is 2 tons. So the amount of weight has to be less than or equal to our 2 tons. All right, so on our last example, we have there can be at most 1,100 people in a conference room. There are 20 tables that can seat 10 people each. How many additional tables that can hold 25 people are needed? So our maximum occupancy for the conference is 1,100 people. Then we have 20 tables sitting 10 people at each table. Plus we need a certain number of tables that can seat 25 people, but we don't know how many tables. So we've got 1,100 is greater than or equal to 200 plus 25t, t standing for tables. Subtract 200 from both sides. And you have 900 is greater than or equal to 25t. Divide both sides by 25. And you have 36 is greater than or equal to t. But as discussed, we always want to write our variable first. So everything about our problem is going to change direction. So we have t is less than or equal to 36.